Welcome, sir! Welcome back sa ating channel!
Hello guys! So for today's video, we will be discussing Mathematics 9 Quarter 1 Module 1, which talks about the illustration of quadratic equations. By the way, I am Miss Rexy and I will be guiding you in this lesson. Let us begin! First, let us know what is a quadratic equation. A quadratic equation is a mathematical sentence of degree 2, meaning to say the highest degree of exponent that must be present on a given equation must be 2. Again, the highest degree of exponent that must be present on the given equation must be 2. It can be written in standard form. But what is the standard form of a quadratic equation? Are you ready? The standard form of a quadratic equation is ax squared plus bx plus c equals 0. I repeat, ax squared plus bx plus c equals 0. Where a, b, and c are real numbers and a should not be equal to 0. Please take note of this. A should not be equal to 0. To further discuss the quadratic equation, let us have again ax squared plus bx plus c equals 0. As you can see on our given equation, we have three different terms. I repeat, there are three different terms on our given quadratic equation. Let us know each of the terms that are present on this equation. First, ax squared. So ax squared is considered or is known as the quadratic term. The quadratic term is composed of a constant, a variable, and of course, the exponent of 2. Quadratic term consists of a constant, a variable, and the exponent of 2. The constant a is also known as the quadratic coefficient or the numerical coefficient of the quadratic term. Is that clear? Next, we have bx. Bx is known as the linear term. The linear term is composed of a constant and a variable. Please take note of the variable. The variable has an exponent of 1. The variable has an exponent of 1. Linear term has also the numerical coefficient represented by b. And lastly, the last term is known as the constant term. So the constant term consists of a constant only. Again, it consists of a constant only. There is no any variable on the constant term. And that constant term is also the coefficient. Now, going back to the idea that a should not be equal to 0. Why? Okay, let us discuss this. Say for example, a is equal to 0. So, we will be substituting 0 to the constant a. Then, the quadratic term becomes 0x squared. 0x squared has no value. And if that is the case, we are going to eliminate 0x squared. So, in short, there will be no quadratic term. And if that is the case, then the whole equation is not considered as quadratic equation. It is not anymore considered as quadratic equation because there is no quadratic term. What are being left are the linear term and the constant term, which happens to be considered as a linear equation. And that is the reason why a should not be equal to 0. I repeat, a should not be equal to 0. Okay, next, let us know more about a linear equation, or let us know the difference between a linear equation and the quadratic equation. Okay, I have here an example of an equation. So let us have the first equation. X squared plus 5x minus 3 equals 0. Is this a linear equation or a quadratic equation? Okay, before you answer that, going back to the definition of a quadratic equation, it says there that in a quadratic equation, the highest degree of exponent that must be present on the given equation is 2. So as you can see on our given equation, we have an exponent of 2, and that is the highest exponent on this equation. And if that is so, then this equation is considered as a quadratic equation. Next, we have here 8k minus 3 equals 0. So, going back to the definition of a quadratic equation, if there is an exponent of 2 and if it is the highest, then it is quadratic. But in this case, there is no presence of an exponent of 2. There is no quadratic term on the given equation. And if that is the case, then it is not a quadratic equation. It is called as a linear equation. Okay, next, 4m squared plus 4m plus 1 equals 0. So, is this a linear equation or a quadratic equation? Okay, very good. Since it has a quadratic term with an exponent of 2, then it is a quadratic equation. Next, 6y minus x equals 10. Is this a quadratic equation or a linear equation? Okay, this is a linear equation because there is no quadratic term. Next, 9r squared minus 25 equals 0. Alright, again, because of the presence of the quadratic term, because of the presence of an exponent of 2, then it is considered as quadratic equation. Next, b squared equals 144. Yes, because of the presence again of the exponent of 2, it is considered as quadratic equation. Next, b squared plus 3b equals 8. Okay, again, because of the presence of the quadratic term, because we have an exponent of 2 over b, then it is a quadratic equation. And lastly, we have 2s plus 3t equals negative 7. It has no quadratic term, then it is a linear equation. Now, I guess you are already familiar with the difference of a quadratic equation from a linear equation. But I would like you to take a look on our given quadratic equations on the presentation. So we have x squared plus 5x minus 3 equals 0. 4m squared plus 4m plus 1 equals 0. We have p squared equals 144. We have also 9r squared minus 25 equals 0. And we have b squared plus 3b equals 8. What have you observed on our given quadratic equation? Okay, so as you can see, some of the equations are not written in standard form. Again, can you still remember the standard form of a quadratic equation? Can you please recite it? ax squared plus bx plus c equals 0. Very good. So as you can see, some of the equations present here are not in standard form. But it is definitely okay. It doesn't necessarily mean that if a quadratic equation is not written in standard form, then it is not considered as a quadratic one. No, it's not. It's fine, it's okay, because there are really some equations that are not yet expressed in standard form. So in this given example, or in these examples, let us determine which are equations that are written in standard form. Okay, so then the answers are x squared plus 5x minus 3 equals 0. We also have 4m squared plus 4m plus 1 equals 0. We also have 9r squared minus 25 equals 0. They are all written in standard form except for p squared equals 144 and b squared plus 3b equals 8, which in fact there are ways on how we are going to change this into standard form. There are ways on how we are going to rewrite this quadratic equation in standard form, and let me show you how to do that. Are you ready? Okay. So we will be transforming equations that are not yet written in standard form to the standard form itself. And after we do that, we will determine or we will identify the value of the coefficients. Okay, is that clear? So let us begin. Let us have example number 1, 2x squared plus 7x minus 15 equals 0. Then definitely it is very clear and understood or obvious that it is already written in standard form, giving us a quadratic term, a linear term, and followed by the constant term. Then it is already written in standard form. So what's next is just we will determine the value of a, b, and c. So how are you going to do that? So the value of a is 2, b is 7, and c is negative 15. So where they all came from? Where are these numbers came from? So a, b, and c are the numerical coefficient on each term. So a came from the numerical coefficient of the quadratic term, which is 2, while b came from the coefficient of the linear term, which is positive 7, and of course c is the constant term having a negative sign. So please take note of this. Do not forget to include the sign of the values of the coefficient. Do not forget to include the sign. It is an important reminder. Okay, next we have 5 minus 2x squared equals 6x. So again, this is a kind of quadratic equation that is not yet written in standard form. So we need to transform this into standard form. How? By applying the subtraction property of equality. Are you familiar with this? Okay, or are you more familiar with transposition? So many of us are fond of using transposition, transpose this to the other side of the equation, but the real score or the real reason why we do that method, or why do we have that method, is because of the subtraction property of equality. So how? This is how we do this. So the main purpose or our goal here is to make the right side of the equation be equal to 0. So in the right side of the equation you have 6x. You have to make 6x 0. How? So by subtracting 6x to 6x. And so since this is an equation, so whatever you do on the right side must be done on the left side. So if you subtract negative 6x on the right side, then you will also have to subtract negative 6x on the left side of the equation, giving us 5 minus 2x minus 6x equals 0. Okay, so do you think it is already written in standard form? Of course, it is not yet written in standard form because of the arrangements of the terms. So we need to rearrange the terms on the same side of the equation by changing the position of the quadratic term, followed by the linear, and followed by the constant, without changing the sign. Okay, so we will not change the sign. Why? Because we are not placing these terms on the other side of the equation. We are not transposing this on the other side of the equation, so the sign will be the same, giving us negative 2x squared minus 6x plus 5 equals 0. So therefore this is already written in standard form, but because of the presence of the negative sign here, I want you to multiply the equation by -1 in order for you to get 2x squared plus 6x minus 5 equals 0, which is also a standard form of the given equation here. But please take note of this. They are not incorrect. This first standard form that we get is not wrong. This is not wrong. It's just that I just wanted to have a positive quadratic term, so that I ask you to multiply it by -1. So meaning to say, -2x squared minus 6x plus 5 equals 0 is just the same with 2x squared plus 6x minus 5 equals 0. They are equal. They are just the same. Okay? So they are just the same. They are both written in standard form. They are just the same. It's just that I just wanted you to have a positive quadratic term here. So therefore, the values of A, B, and C are A for the quadratic term, numerical coefficient of the quadratic term is 2. B, the coefficient of the linear term is 6. And C is the constant term, which is -5. Okay, next. Example number 3, so we have here a monomial multiplied to binomial equals 2, so x times 3x plus 5 equals 2. So, of course, without the presence of the exponent of 2, you may be confused if this is a linear equation or a quadratic equation. But definitely, it is a quadratic equation. So, it's just that it is not yet written in standard form. So we need to rewrite this in standard form by applying the distributive property. Then, can you still remember how to apply distributive property? It's the way of multiplying the monomial outside the parentheses to each term on the binomial or polynomial inside the parentheses goes like this. X multiplied by 3x, getting the product of 3x squared, and we also have x times 5, having a product of positive 5x, and then bring down 2. Okay, so after this, we need to apply the subtraction property of equality, also known as transposition. But of course, anyway, then you will get 3x squared plus 5x minus 2 equals 2 minus 2, giving us the simplified form of 3x squared plus 5x minus 2, which is equal to 0. So again, whatever you will be doing on the right side of the equation, it must be done on the left side of the equation. So here we will get 3x squared plus 5x minus 2 equals 0, and then therefore this is already the standard form of the given equation. Now let us determine the value of A. Okay, so now let us determine the value of A. And so the value of A is equal to 3, and the value of B is equal to 5, and the value of C is equal to -2. Do you have any question? So if you do not have any question, let us proceed. So our next example is x minus 2 times x minus 10 equals 0. So again, we need to simplify this for us to get the quadratic equation that we will be needing. So how are you going to simplify this? By applying FOIL method. Can you still remember FOIL method? FOIL stands for the first terms, outer terms, inner terms, and the last terms. So let us do it. So the first terms of our given binomials are x and x, giving us the product of x squared. Outer terms are x and -10, giving us the product of -10x. Next are the inner terms, which are -2 and x, giving us the product of -2x. And of course, the last terms are -2 and -10 with +20 as their product, which are equal to 0. Okay, so we have x squared minus 10x minus 2x plus 20 equals 0. then followed by the combination of the similar terms. So are you familiar with the similar terms? So when we say similar terms, these are the terms having the same variable of the same degree. So meaning to say, same ang variable with the same exponent. So which among these terms are the similar terms? So of course, we have negative 10x and negative 2x given that they have the same variable x with an exponent of 1. Okay, negative 2x, it has a variable x with an exponent of 1. So if we will combine them by addition, we will copy the sign because they have the same sign. We will copy the sign. We will add the numerical coefficient, and then we will copy the variable. So giving us x squared minus 12x plus 20. So how did we get negative 12x? Again, we add 10 and 2, getting 12. We copied negative and negative, so they have the same sign, so we will copy the same sign, which is negative, and we will also copy the same variable, which is x, and then bring down positive 20 equals 0. Then definitely this is already written in standard form, giving us the value of a, which is 1, of course. Always remember, if a given term has no numerical coefficient, it is understood as 1 as a coefficient. And for b, we have negative 12. Again, do not forget to include the sign. It is very important. And c, we have 20. Okay, so going to the last example, I have prepared here a word problem. Let us read. The length of a swimming pool is 8 meters longer than its width, and the area is 105 square meters. Again, the length of a swimming pool is 8 meters longer than its width, and the area is 105 square meters. First, we need to have the representation of the given problem. So of course, I guess we should have a rectangular swimming pool here, and the dimensions are the length and the width. The width will be represented by x, I guess, and the length will be represented by x plus 8 because of, it says there that the length of the swimming pool is 8 meters longer than the width. So that is why the width is represented by x, the length is represented by x plus 8, and of course the area is 105 square meters. Now let us have the area of the rectangle. So we have area equals length times width. So by substitution, you will get 105 equals x plus 8 times x. And by applying distributive property, you will get 105 equals x squared plus 8x. So how did we get x squared plus 8x? By multiplying each term of the binomial to the term outside the parentheses or the monomial. And then by the symmetric property wherein we change the position of the terms on the right and the term on the left. So that is because of the symmetric property. Next, again, we will apply subtraction property of equality, or what is also known as transposition. We need to make 105 be equal to 0, so we will subtract 105 on it. And we will do that on the same side of the equation, giving us x squared plus 8x minus 105 equals 0. And then this is considered as the standard form. Now let us determine the value of a. Again, the quadratic term is x squared. So it is understood that the coefficient of the quadratic term is 1. And for the linear term, we have 8. And of course, for the constant term, we have negative 105. So that's it. So that's how the illustration of quadratic equation all about. So at the end of the lesson, you have learned how quadratic equation can be used in real life situation, just like this example. And you have also learned how to differentiate a quadratic equation from a linear equation. And also, you have learned how to rewrite or transform a quadratic equation into standard form. And added to the lesson is how you will identify the value of a, b, and c as the coefficient of our quadratic equation. Okay, so if there are no questions, if you have already understood it, okay, so that's it for today. That's it for this lesson, and let us see each other on the next video. Good luck!